If you built a water cool system, then you know it kind of sucks sometimes, especially if it's a small case to try and figure out where the heck you're gonna put your pump and whatnot. That's why EK putting it on the block now, at least with the Quantum Velocity 2 CPU water block combo unit. The Montech Titan Gold ATX 3.0 power supplies feature a Gen 5 PCIe power connector for adapter-free 40 series GPU installation, and is available in 750, 850, 1000, and 1200 watt versions, giving you the power needed to power today's demanding PC components. 100% Japanese 105C capacitors provide improved performance, while the 135mm fluid dynamic varying fan with 0 RPM mode keep all components cool, even during the most demanding workloads, all while the 80+ gold rating and 10-year warranty provide end user peace of mind. Check out the Titan Gold lineup of Montech power supplies by clicking on the sponsored link in the description below. Okay, so like I just said, this is a combo unit. So what they've done here is they basically take, this is like an AIO pump block cold plate combo unit on steroids, and then taking more steroid to get on top of it. So typically when you find like an AIO, you'll see there's like an Asetek pump in there, a little impeller, very low flow, very low pressure, very thin cold plates, and although they get the job done, they just don't carry enough thermal mass in terms of the amount of metal that's on there to really be able to compete with like standalone water blocks and open loops. That's the reason why open loops are still better than AIOs, is because their overall thermal capacity and build quality is much higher. However, it's kind of, I wish something like this existed way back when. I know SwiftTech had made one way back in the day. I believe Coolant's even made one for a while there, but the problem was the pump quality back then was not like it is today. So in terms of the pump, this is a DDC 4.2. So if you guys know what the 12 volt DDC pump is, it's not the D5, it's the smaller version, but it's known to be very high pressure and very decent flow, whereas a D5 would be high flow, lower pressure. This is a great combo unit to have if you have a small form factor build and you're trying to get as much space available as possible. You technically wouldn't even need a quote unquote reservoir with this, but it would definitely make things easier to fill and bleed if you needed one. So the downside is when it comes to EK's blocks and their designs now, they are specific to the socket. So depending on like the Velocity for sure, the Velocity 2s are specific to the socket. If you go with like the old Quantums, a lot of times they'll have a bracket that you can change to make it work with AMD or Intel, and that's kind of nice to see. But if you go with the Velocity 2, you need to make sure you get the one that's designed for your socket, whether it's gonna be AM5/AM4 or Intel. So this is Intel 1700, so it wouldn't even work with like an old 1156, 1152, 1366. It has to be specific to the socket type that you're using. But anyway, it is a PWM. It has 6 G-quarter thread ports on there, so that's gonna be nice to see because of the fact that when it comes to routing your tubing and stuff, having options is important. Now this is heavy. This is a heavy unit. If you've ever looked at the Velocity 2 block in person, then you know they are chonkers and a half. This guy, this is also the full nickel one. So that means the top is nickel. Holy crap, this thing is just thick.
Just cooling cube.
It's like a Tesseract cube of cooling. Anyway, as you can see here, we've got 2 ports right here. So if you have this on a motherboard, you can use the top. Depending on whether or not you've got it angled a certain way, you could also use the side ports. Now this is gonna be nice because if you're dealing with small form factor and you add a ton of height with fittings, and you can fit these on the side, not have it interfere with RAM or VRM coolers. That's the only downside about 1700, is the fact that your RAM tends to be kind of close to the socket and the other sides all seem to be blocked off by really tall VRM coolers. You're probably gonna be stuck using the top anyway. However, if you're trying to build a small form factor, the height is definitely gonna be of concern, but having the options is nice. And then we have a port here and we have a port here. Now these extra ports that you're not using would be kind of nice to help sort of prime the pump and get some fluid in there. But the biggest concern now, when you go with something like this, is going to be feeding the pump with fluid. With a closed loop, we've talked about this before. If you have the pump higher than the radiator, because the pump is built into the block, so if you have the block and the pump higher than the radiator, gravity is not feeding that pump. So getting it primed and getting it running would be extremely difficult because a water pump cannot move air. It moves fluid, not air. So you'd have to like flip your system over to get it all running, and then once you flip it back, what's gonna happen is the air is gonna collect at the highest point in the loop. If that highest point ends up being the pump, then again, you're gonna have aeration and you're gonna have cavitation, and then you're not gonna be moving fluid again. There's been lots of videos all about this where you know, companies that are showing like water pumps on top with a radiator at the bottom, it's like completely doing it the wrong way. This introduces that concept into your open loop systems. So you need to keep that in mind. What needs to be feeding the pump is fluid, which means the pump cannot be the highest point in your loop. So if you were putting this again as like say like Phil's NR200P Max build or something like that, if you don't have a radiator on top, if you have it on the side or even on the bottom, if this is the highest point in the loop, it's gonna create some concerns. Now the DDC is a little bit better able to handle getting cavitation out. So as long as there's any fluid level above it, it's going to be fine. If you have a radiator on top or a front mounted rad, as long as that radiator has a point that's higher than the pump, it's gonna be okay. But it's just a new thing you're gonna have to consider now when it comes to running this particular combo unit in a system. So a lot of times, these are the kind of things that maybe a person doesn't consider if they're running a combo unit like this. Now I wish that combo units like this were a little bit more plentiful back in the day, because it certainly would have come in handy, but you can see the DDC, it's basically built into the acrylic right here. You can get this in plexi. This is plexi, not acrylic, but you can get it in plexi, you can get it in acetal, black, same thing with the top here. It's all kinds of different material combos that EK's come out with. But what I'm gonna do right now is I wanna sort of take it apart, because I'm kind of curious as to what the build philosophy is here when it comes to like what the flow is. I wanna see what the ports are like. Is there any sort of capacity inside of here that works as maybe like a tiny makeshift reservoir, just to make sure it always has some sort of coolant feeding it? But because it is your combo unit, you have a few wires coming off of this, which fortunately are black, they're not sleeved. They are 2 wires per harness here, except for the ARGB, which is 3. We have an ARGB standard 3-pin plug for a motherboard. We have a SATA power, which is gonna power the pump. And then we have our 3-pin, technically 4-pin PWM, which has both an RPM wire and a PWM signal going to it. So all power comes from the SATA plug. All signaling comes from the PWM harness with the RPM built in. You can see on the back here, we have the thumb screws, which are kind of a new addition to EK, which is kind of nice, so that you're not ripping all of the skin off your finger trying to turn these. But this is the backing plate. This is what's gonna go on the back side of the Intel socket, which is gonna give it its retention. Pressure and mounting pressure and tension are extremely important for water cooling. I'm not sure that was supposed to come all the way out. I think that was supposed to be captive, and I think it just popped out. So I guess we're gonna find out right now. Yeah. So I think all that happened here is I unthreaded it through there, let's see. There's a little C-ring that has to be compressed, pushed back in there, and then there's a lip inside that hole that it pops in. Now I can get this back on, but unfortunately, that was not supposed to come off. So if that doesn't get put back in there properly, that's gonna affect the tension on this side of the block. So that means we have 3 tighter screws than this one. Technically this would be tighter because it doesn't bottom out. All right, so as I take it apart, I need to be mindful of which way the plate is facing, otherwise the flow will be wrong. So the letters are facing the wires, I'll remember that. Use my trusty iFixit kit to take this apart. Should be pretty straightforward. All right, so you can see here, this is the jet plate. This is the piece of metal that is responsible for touching and cooling the IHS. It's pretty thick. You can see the amount of cooling fins that's in there. The reason why they do that is it means more surface area. It allows you to basically have more mass of metal touching both the coolant and the CPU IHS, which is gonna give you as much cooling as possible. But you can see this guy's pretty thick. It's got an O-ring in there to seal. And then this is the flow plate. So this is what the coolant comes down through. So it basically lays like that in there. So the coolant is forced to go down into those fins and then out each side, and then it kind of flows back on itself and then out of here. So this is the inlet, and then those are the outlets where it goes back to the different ports that are on there. These are threading into the plexi, so you definitely don't want to over tighten those. Oh, there we go. So you can see the RGB is literally just a strip right in that channel. And so it's side lighting through, but you can see the flow now, right? So it comes down through there, and then when it returns, it goes back through there and then back through here. So technically this is coming, going back out. So it's pump, going straight down into the CPU, and then those come out and reconverge into the different fittings. A lot of pieces to this. You should never really have to service this. And the reason why I check this serviceability is because of the fact that if you've ever used a coolant that started to gunk things up, then you know that these little micro fins in here can get chunked up and clogged up pretty easily. The finer it is, the easier it is for debris or any sort of corrosion, which unfortunately it happens every now and then. You can't account for all the different types of metals that are in a loop, and although you'll hopefully use the kind of coolant that maybe wouldn't be known to cause clogs, it absolutely can happen, does happen, and will happen. So serviceability is important. We saw getting this off to clean, it's just the 4 screws, super easy. And then this, there's no brainer on which way that goes. You can see those grooves in there. It's very groovy. It's a lot of screws that are going into this combo unit. It's complex, it's probably very expensive because EK products are very pricey, which is why for the price, I'm very disappointed about that retention piece not being in there. It seems like the last few times I've done an EK product of some sort, I am left with some sort of disappointment about it, which is kind of sucky. All right, so there's a side piece. They didn't even double-sided tape it.
They didn't peel the thing?
No. Like, is there a reason why they wouldn't have done that? I can't think of a reason why they wouldn't have taped that in there like it's supposed to go. Fine, I'll do it now. I guess I'll do their job for them.
Literally doing EK.
For the record, I didn't request this, it just showed up, so. I take it as, if it just shows up, it's here, tell us what you think. I'm tough on water cooling stuff, because my issue with water cooling, and EK is not one of the brands that does what I'm about to say, but as water cooling became more mainstream, see now it stays in place. Like, laziness is all that is. Now that water cooling's become more mainstream, you have a lot of brands that are just kind of half-assing it to get their name in the hat, and that way you might have a chance of buying their stuff, and I find that to be shoddy at best. Okay, so this is just the center piece that does nothing but give the pump something to mount into, and then it's basically like a distribution block. You can see all the different flow channels in there. So that's intended to give the fluid a pathway to go. I don't know why I went Lena's voice for a second there. But anyway, I like how everything is sealed up with an O-ring though. That one just kind of stayed stuck. The DDC uses a very similar impeller to the D5, but it is a little different. It has a ceramic bearing right there that it floats on. This is why I tell people all the time, never, ever, ever run your pump dry. It is lubricated by the coolant that it is moving. So if I were to turn this right now, it's not making a squeaky sound. It is magnetic, as you can see, it's just sort of floating in there. But the ceramic bearing is making full contact. Now it is kind of a nylon, like a black nylon in there. It used to just be metal. Metal and ceramic don't go together very nicely, but they've thought about the fact that no matter how many times you can warn people, people don't like to listen to warnings and will just ignore and do whatever they want, and then they turn it on to see if it works without any coolant, and then it makes a squeaky sound and they're scratching their bearing, which can lead to problems. They now have a nylon sleeve in there, which gives it some lubrication on that ceramic bearing, but the coolant does go down through there, which gives it something to lubricate it with. And then the pump, I was trying to see if the pump can come out, because this is technically the pump housing, and it's very heavy because of the fact that it's all either brass or copper, probably brass. For all intents and purposes, this is the size of a standard DDC, and realistically, a regular DDC could potentially just fit in there, but they probably have this glued in there. This does not feel like it's intended to be serviced. Yeah, that's glued in there, I'm fairly certain. So that's it, fully disassembled. As you can see, lots of parts to this one, some of which may or may not be attached in the way they're supposed to be, which is very disappointing to see, especially in a brand like EK that you know for a fact is charging a premium for this. Like, I have to see now, do we have a price on this yet? Now, I'm gonna guess without even looking yet, for being LGA 1700, I know how much the block itself would cost. I know what a DDC costs. I know that this is now bespoke. I'm gonna say $419. Oh, $319. Okay, I was $100 off. I was right on the 19. That was the hard part, in my opinion. $319. Okay, I don't personally feel like that's a ridiculous price. It is expensive. It's very expensive. You can buy a graphics card for that coming up. Probably you could buy a 4060 non-Ti for that. I don't know what the pricing is on that yet, but given the fact that, as you can see, the amount of craftsmanship that goes into this, the convenience of having an all-in-one block and pump that would give you a lot of free space, as long as your build can account for the fact that you need to now make up for the fact that you don't have a reservoir directly feeding your pump. I love pump res combos. Pump block combos are really nice to have in builds where space is limited. This is also nice to have if you want to add another pump to your system. Now, why might you want to add another pump to your system? Look, if you're running a big 1000D or something like that, or you've got a build that's got 3 radiators, and then you've got it going through a GPU block, and you've got it going through a CPU block, and then you've got, I don't know, maybe some flow meters on there, or some other things like even distribution plates that can add resistance. Every single time you have a 90 in your loop, even though a lot of the 90s now are very curved to improve flow, anytime flow has to make a change in direction, especially a sharp one, you have a pressure drop. So this would also become very handy if you were doing a build, say, multiple rads, a GPU, a CPU, maybe RAM blocks or something, distribution blocks. You could run a pump res combo and this pump on the same, in the same loop to pick up that pressure drop. So what would end up happening is I would match a DDC with another DDC, and then I would put both of the DDC PWM signals into a splitter and then have that splitter running off of one header. That way the pumps always stay at the same speed. Because if you have one pump running slower than the other, although it does help, you can get some odd sounds in your loop as you have pressure changes as they kind of go across the pumps that are operating at 2 different speeds. So that'd be my recommendation, 2 DDCs matching, 1 pump res combo, 1 on the CPU block, and then you have basically, it's kind of like the old Hot Wheels track, right? So you've got the accelerator that pushes the car through and the car starts to lose speed, and then it hits another one and it goes faster. This just keeps the speed consistent through the whole track. All right, guys, thanks for watching. Hope you learned something with this teardown. It's kind of neat. I think if I do end up switching my system over to Intel, I might throw it on there. The problem is, my loop has a D5. So I guess I'd be doing a DDC and a D5 against the suggestion I just made. Do as I say, not as I do.
Okay, so how, and what happened?
I got it back on, but it's on the wrong side.
Turn it around.